Go to the next thing. All right, so the next word that we're going after now is that word called instantaneous. It's not between the 2 points. It's at that point. It's at that point. So let's come here. Look here, because there is some type of an example here. It says, find the speed. They didn't say average. Do you see that?
Yeah.
Yeah. They say, find the speed, no longer average. So your mind cannot say, give me 2 points now. No, you can't, because you didn't see the word average. But I told you, once you hear the word average, before you can read the whole thing, just say, give me 2 points, please. Yeah, exactly. All right. All right, so this one says find the speed. So no point. And then of the following of the falling rock in that example we just did. Now it says, watch now. It says at. It's no longer between. So I'm stressing that letter at. It's at t equals to 1. Actually, this might confuse you because there's also 2 seconds. It's actually at t equals to 1. You must do for that one. And come back, do another one at t equals to 2. So that means it's from, when I'm looking at the first one, the one at t equals to 1, it means you begin at t, let's call t1, let's make it 1. You begin at t1, which is 1, and then you're gonna end up your T2, it's also on the very same spot right there at T equals to 1. So T1 and T2 are basically that 1, both of them. You understand what I'm saying?
Not really.
Okay. All right, let's do this. Let's say maybe you are walking, right? You're walking from one point to another point. Now, I'm just gonna draw a line. Here's a straight line there. So you're walking from point A, and then you're going towards point B. There we go. Now, the moment, let's say you're going to start when time is 0 here at A. T1, it's actually 0. So I'm looking at my stopwatch, it says 0. Then I said, please walk, begin to walk to point B. Then you walk, you get by point B, which is your second position at T2. Am I right?
Yes.
When I look at the clock, now it says 5. Oh, then I can say, wait a minute. The distance was between A and B. At the beginning, you had, your time was 0. We good, right? Yeah. So what am I saying? I'm trying to work out the distance or the average, whatever, between 2 points, A and B. I'm saying between. You know what I'm saying? I told you that I'm stressing the words between point A and B. Give me the time from that took you to travel from A to B. But now, when we change the game, you are now here at point A. We're starting all over again. We say, okay, you are now here at point A. At point A, your time, let's say that T1, whatever that time is, what we can make it 3 for now. Let's say it's 3. Then I'm saying, I'm actually want to measure from A to A. Think about a tape measure. Let's go back to AB. If you take a ruler, you can measure a distance from A to B, can't you? You can, isn't it?
Yes.
Okay. So the difference from there to there, maybe you could just subtract whatever it is, but I'm not going to go too much crazy. Let's just say you get 10 meter. How did you get 10 meter? Point B minus point A, correct?
Yeah.
All right. Let's say on the number line, maybe point A was basically at point where it says 2 meters, and then the B is actually at 12 meter. So it's basically 12 minus 2, which is 10. We're okay with that one? All right. Now, Now let's measure. Now we say now we're gonna do the same thing, but this time you are not budging. You're not gonna move. You are not moving at point A. You are not gonna move, and then we wanna measure your distance at. I'm not saying between. Understand what I'm saying?
Mm-hmm.
We're saying the distance at A, at that point. Come on, to measure a distance, you need to move from A to another point, isn't it right?
Yeah.
Yeah. All right. Remember the distance that you travel from 0 seconds to 5 seconds, it was 10. So let's just do the same thing here. Let's say now you stay at position A, and then after some minutes, when time is now, let's say, let's make it 8 seconds. You are still in position A. All right, I know it's telling you 10 minutes. We're going to jump back again. Now, then the question says, since you've been sitting here at position A for the last 10 minutes, how much distance have you covered from position A to position A since you never moved? We are saying the distance at A. So what I'm trying to tell you, I'm simply trying to tell you, measure from A to where? To A. A to A. Am I correct?
Mm-hmm.
Because you never moved. You never budged. So you can't even move. You can't even, I mean, like, dude, I've been here for the first 5 hours or the last 10 hours. So your distance from A to A, it's 0. You never moved. You were there all along. That is at A. But the 10 meter, it's not the distance at A, neither the distance at B. It is the distance between. Yes. But this one at A, it simply means between A and A itself. Come on, it's 0. Am I right?
Yeah.
Good. That's what I was trying to make you understand.
Oh, okay.
Because they say find the speed of the falling rock when the time is at T is 1. So that means when the clock says 1, you are at position A. But they didn't ask you when it has passed T1. No, they just say right there at T1, where you at. So that means you mean I must measure from here to here where I am? You see, it's 0, isn't it?
Mm-hmm.
All right, good. So that's exactly what I was saying. I was saying the time was 1, and after some duration, some moment, you are still at the same position at T1. T2, T1, they're exactly the same position. I don't know if that made sense to you.
Yes, it did. Thank you.
Okay. All right, fine. So if that made sense, now, so that means I was saying when they say at, that's the key word, at T equals to whatever, let's make it 1. It's the same thing, meaning, okay, let's call it T1. It's the same thing as using, if you want to use the word between, it's between itself. It's between T1 and itself, T1. You get it? Yes. So meaning the first time the T1 was actually T1. And then the second time T2 was still T1. I hope you got it now. You got it?
Yes.
All right. Good. That's what I wanted you to understand. Now, the problem is this. Watch now. Watch. If we do the gradient, the average speed, I'm going to write speed average, all right, equals to, we need to, at the top, as we did with that equation, we needed the y2 minus the y1, and then we needed to divide it by T2 minus the T1. We good, right?
Yeah.
But bear in mind, T2 is the same as T1. So that one and that one is exactly the same number. It's the same thing.
Yes.
Good. So even though you were to substitute, all right, let's say we substitute, we're using that equation. We had that equation there, which was 16t squared. We can substitute in it if you want to, but it's not going to work. I'm telling you in advance. So we had 16t squared. So that means you will say, all right, when time is 1, that is your T1, what will be my Y1? You see, you're working it out like how you did with the average gradient. So at that point, it is the same as average gradient, but it's between the very same point, not two different points. That's where the catch is. Yeah. All right. So if you put a 1 there, it's going to be 1 squared. You get a 16. Then you say, okay, I need the second point. I need T2, but T2 is also 1. So I'm also going to get 16 there. Can you see that?
Yes.
Now, let's do the substitution here because this is Y2. You say, okay, Y2 is 16 minus Y1, which is also 16, and then divided by T1, which is 1, minus T1, which is also 1. Then we have a problem now. Mathematically, we now have that's when we encounter a problem. I'm going to put it in. And that denominator, because in a true sense of it, at T, you are supposed to use between itself, like how I did it with these two red ones here. And then you substitute, you work out the answer exactly the same way we did with the average. Can you see that?
Yeah.
Yeah, so it's an average between itself. So, but then the problem is, like what you just said, when we do it that way, we encounter a problem, it becomes undefined. It becomes undefined. We're like, oops, oh my God, I can't even get an answer. So how can I work out an answer for this thing? Because if I do it the normal way, it does not work. So we must come with a strategy how to do it. Do you get it now?
Yeah.
All right. Now, here's the key. I want you to look at that. We are going to look at T2 minus T1. In our case, it's actually 0. That T minus T2 minus T1 is delta T, which was our delta X. Normally, I'm just getting ahead of myself. We also call it H, isn't it right? Yeah. So that's the bottom, that delta T, delta X, that H. So if delta H here at the bottom, if we have a 0, we get undefined. Then we're like, okay, let's come up with a way how to figure out this thing. So we will say, can we make delta H not to be 0, that delta T? Let it not be 0, because when it's 0, we get undefined. Can we work with delta H or delta T or delta X, which is so much close, so very close to 0? It's not 0, but it's very close to 0. And then we work out the answer. The answer that we'll get, it will be so close to the real answer of delta H equals to 0, because I'm using delta T. It's almost 0, not quite 0. Therefore, the answer that we're going to get, it must be almost the correct answer as well. Do you get the sense what I'm saying now? Yeah. So that's why they start saying, all right, let's take that delta T. We can give it values which are not 0, but closer to 0. We can go with 0, let's say 0,1. You can go 0,001. You can make it to be 0,000000000. Once I put 1, it's not quite 0 yet, but it's extremely almost 0. Can you see that?
Yeah.
That means the answer approaches the true answer we would have gotten if the 0 was to work, but it's not working. It's giving us undefined. Aha, I know, I can see that it's saying less than 1 minute here. Let me cut it, stop it here, and then you're gonna have to jump back now. Okay, I'm just